Hey guys, in this video I'm going to show you how the Pythagoras theorem makes sense in a visual way. Let's get to it. First, I'm going to explain how the Pythagoras theorem works. The Pythagoras theorem only applies to triangles with one 90-degree angle. These triangles are called right triangles. And over here we have a right triangle. Let's call the sides of the triangle A, B, and C, and the Pythagoras theorem states that the length of side C squared is equal to the length of side A squared plus the length of side B squared. And this theorem goes both ways. If we have a right triangle, this equation is satisfied, and if this equation is satisfied, then we have a right triangle. Now let's draw squares on each side of the triangle. The squares have the same side lengths as the side on the triangle they are represented on. So this square has the side lengths A and A, so its surface area becomes A squared. Let's do the same for the other two sides. This one has the sides C and C and has a surface area of C squared. And this square has the side lengths of B and B, and the surface area of this square is B squared. So what the Pythagoras theorem is really telling us is that the surface area of the blue square is equal to the surface area of the green square plus the surface area of the red square. This is not obvious, so let's take a closer look on how it makes sense. To explain it visually, we start off by drawing one right triangle. This right triangle, of course, has a 90-degree angle. And let's call the sides A, B, and C. Then let's draw a square. Inside the square, we draw four triangles of the same size as the original one. We arrange them like this. And to make it more clear, I'm going to color the triangles. Then we can see that this part is equal to A, this part is equal to B, this part is equal to A, and this part is equal to B. That is because all the triangles inside the big square are of the same size as the original one. Then we draw another square of the same size as the first square. Inside this square we also draw four triangles, but we arrange them differently. I'm going to color these triangles as well, so it becomes more clear. The sizes of the triangles inside the square are also of the same size as the original one. That means that this side over here is equal to B, this side over here is equal to A, this side over here is equal to A, and this side over here is equal to B. Now we get to the fun part. We know from this triangle that the length of this side is equal to C, and the length of this side is equal to C as well. That means that the surface area of the empty space inside the big square is equal to C squared. And in the other big square, we know that the surface area of this empty space is equal to B squared, and the surface area of this empty space is equal to A squared. And since the surface area of the red, blue, green, and yellow triangles in both of the big squares are of equal size, then the surface areas of the empty spaces in both big squares must be equal to each other. That means that C squared equals to A squared plus B squared. This is one of many proofs the Pythagoras theorem has. If you learned anything from this video, please give it a like and subscribe to my channel for more math videos. I will also link down in the description some Pythagoras examples that you can try out for yourself.